Thanks everyone again for pulling in and joining us. So my name is Nathan. I'm from Stage Audio Works based in Joburg. I oversee our efforts in especially projects as well as all other technical things. And I'm joined by my kind colleague MCS Smith, who kind of does the same in Namibia in our office over there. So yeah, the topic of today is about QSE Q-SYS. So this is the first kind of, let's say, really product specific sort of event that we're hosting, especially with the current sort of trend in video conferencing and what we're going to see in the months coming up about meeting rooms and huddle rooms and all of that sort of thing, to have a good indication of what's possible with this platform. So yeah, let's dive in. What we're going to look at today basically is just an introduction to QSE as a company, and an introduction to the Q-SYS ecosystem, as we call it. Then we're going to look through a kind of conference room, and then a larger centralized system, and then a really large centralized system, and then a couple of the Q-SYS standards and principles, as well as an enterprise core. So most of you guys that are familiar with QSE as a brand know it as a power amplifier manufacturer. So the company was founded in 1968. So already more than 50 years old. And the first product that the company QSE made was a guitar amplifier. Q stands for Quilter, which is Pat Quilter. He was the founder of the company, and SC for sound company. So later on, they kind of swung around from guitar amplifiers into doing power amplifiers for audio, and they built a reputation for being highly reliable. I know in the earlier days of my live sound endeavors, the QSE like PLX and that stuff were really rock solid products, and I've seen some of those in the field now that are well over 20 years old. So people really respect the reliability of the QSE amplifiers. But in 2004, the company sort of took the first step into becoming a more let's call it an audio systems provider rather than just an amplifier manufacturer. So they started manufacturing loudspeakers, and they came up with a complete line, including a line array system called Wide Line and a whole range of installation products, and then moved into this portable PA market. So you see these plastic speakers called K-Series, and they have a little digital mixer. But yeah, I mean, the trend really, well, let's say the effort really pushed into systems, as we call it, in 2008 with the launch of Q-SYS. So in the recent years, the QSE business has kind of been restructured into three divisions. Live sound, which is the traditional business of QSE, which manufactures amplifiers and loudspeakers for, let's say, touring and portable applications, as well as higher performance installs. And then we have the systems unit. That's what Stage Audio Works represents across South Africa. And that basically comprises of all of the products targeted at the fixed installation market. And then the cinema division. It's interesting that apart from maybe the largest competitor in that space, which is Harman with JBL, QSE is probably the largest manufacturer of cinema audio loudspeakers in the world. In the States, they have about a 40% market share, in other parts of the world as well. And recently, they've started integrating Q-SYS into their designs or into their products for cinema applications as well. So that's a big business for QSE as well. But yeah, I mean, at the time, the audio video control space was quite disjointed. So there wasn't really a manufacturer that was taking a complete turnkey look at what's needed for audio video and control in a single project. So you would have a company that was manufacturing audio DSP, and then another company that was doing the control system, and then some video bits, and all of these things had to be integrated quite tediously. So QSE's approach is to kind of develop what they call the Q-SYS ecosystem, which compromises of audio, video, and control. So in software philosophy, in computing philosophy today, there's generally a trend away from specific products and into this kind of platform concept. If you think about an iPhone, for example, not many people are buying iPhones because the hardware is something special that another company couldn't make, but the whole iOS and App Store ecosystem, the whole platform that an iPhone, for example, presents, is kind of what's attractive about it. And what QSE is doing is trying to develop an audio, video, and control platform that's really tightly integrated with hardware and software options that really work well together with minimal pain and suffering from an integration perspective. So yeah, that today is what we know as the Q-SYS ecosystem. And yeah, they are the cornerstone features there: one manufacturer, one shared vision, one development team, and a single platform. So yeah, what makes Q-SYS different is that the way that the hardware and the whole system has been structured. So at the core, no pun intended, of the system, we have a device called a core, which is the central processor of the Q-SYS system. So at the moment in the product portfolio, we have three models. One is a Core 110F, which is what QSE calls the unified processor, and we'll get into why these are nameless in a minute. A Core 510, which is basically a Core 110 with 8 times the amount of DSP power, and then the Core 5200 for really large applications. And what sets Q-SYS apart from, let's say, some of our competitors, especially in the audio DSP space, is that the architecture is really different. So Q-SYS is developed on an open stack, so we don't use any proprietary DSP chips to do any processing. It's essentially, a core is an Intel-based PC that runs a custom Linux operating system that does all of the audio and control processing in real time. So this wasn't possible until a couple of years ago, but advances in IT technology have enabled this now, that we can process audio in real time on a generic x86 CPU. And then combined with Linux and obviously being on an Intel-based IT platform, we're using IEEE-based standards for transport over the network. So this is basically what Q-SYS is. So if we have to do some comparisons about what's possible with processing headroom of Q-SYS compared to some of our competitors, we drew up a simple design with this signal processing chain and just try to compile it in various manufacturers' design softwares. So, if we have to look at how many times we can implement this sort of processing chain in some of our competitors, you could see that more or less where the Core 110 hits its limit which is our base level processor, is where the others are already maxing out. So the power offered by the Intel processor is kind of unmatched. If we look at our bigger units, like the Core 510 versus the biggest units from our competitors, we have 12 times more processing power. So what this enables, apart from obviously incredible performance, is the fact that we can build really flexible and centralized system designs. So with other products, you would need multiple DSP processors to achieve a distributed system. So if you had several different meeting rooms or auditorium spaces in a single facility, you would need a DSP processor per room, for example. But with Q-SYS, you can employ a kind of centralized design with a single processor handling numerous things. And apart from the incredible, let's say, audio processing power, we have a lot of, various other features which are not offered by traditional audio DSPs. The biggest one of those being control. We have the ability to do things like multi-track audio playback, up to 128 channels from a core. So this enables, projects that traditionally you would have needed an external audio playback system or a show controller. We have a timeline controller built in, so you can do kind of rudimentary show control stuff. So Q-SYS is a really flexible tool for not only corporate AV spaces, but for a wide variety of different applications. But apart from all of that, let's quickly dive into some of the specific features that are offered by Q-SYS. So from an audio perspective, we have a proprietary, well, not proprietary, it's a network protocol stack built on a pile of open standards called QLAN. And we have a variety of different peripherals that can connect to a core processor over QLAN. We also support, all of the other major network protocols. And most recently, as of last week, the core can natively receive and send out Dante audio streams with no additional hardware. That's also a major benefit of being a totally software-based ecosystem, is that we can, in the process of a single firmware update, roll out major new features. If you think about doing this with a hardware-based DSP, you would need to add a Dante Brooklyn card to add Dante functionality, but for us, it's just about a firmware update. So at the moment, the Core 110 can support up to 32 in and 32 out on Dante, and that's this additional license that you would purchase. And in the future firmware, Core 510 and Core 5200 will be able to support up to, I think the 5200 will be able to do 512 Dante in and 512 Dante out, up to the software licensing. So that's a really powerful thing. some of the other peripherals that we offer in the QSE ecosystem is a full range of amplifiers, including our CXQ series. So these are QLAN peripherals, so they can connect to the core via Ethernet, and that contains the full telemetry, so we can read a lot of data back from the amplifiers. And we also have a full range of loudspeakers at various price and performance levels, which are very good. So from a single manufacturer, again, you could purchase an entire audio system except for maybe microphones, and it's all integrated into a single control platform, which is really good. So yeah, these are just a brief overview of the amplifiers we have. So the smallest ones in the range are SPA, so half rack with no fans, passively cooled, I think up to 4 by 100 watt in a half U rack. So for powering a meeting room kind of system, this works really well. We have a new MPA series, which was brought out as part of the QSC business music platform. And this can do up to 8 channels in a single rack unit. And the beauty of this amplifier is you could run channels in a mix of low impedance and high impedance mode. So an application in a maybe a business music or a hospitality application where you had maybe a 100-volt line system for paging and then some low impedance speakers for background music, you can power this on a single amplifier and change those settings on a channel by channel basis, which is quite flexible. And then for high power, up to 8 by 2 kilowatt, we have the CXQ series. We'll talk a bit more about that in detail later, some of the flexibility that offers. But in terms of loudspeakers, we essentially have 4, let's call it series or product families. Acoustic coverage, which is a really low cost range of speakers. Then acoustic design, which is our flagship sort of installation speaker range. Acoustic performance for higher performance applications like maybe nightclubs or churches or something like this. And then we have a dedicated installation line array product in the QSC systems range as well called ILA. So what about video? Yeah, Q-SYS offers what we are calling network native video distribution. So we'll dive into this in a bit more detail, but we have essentially 2 video product offerings. We have a webcam, an IP webcam solution for soft codec conferencing. So we're able to present to a computer a driverless USB speakerphone and webcam. So a user could walk into a boardroom and plug it in. And that eliminates all of the HDMI and USB devices needed to make that happen traditionally. The second part of the Q-SYS video offering, which is the most recent, is we have a video over IP that's competing against the likes of NVX and Atlona OmniStream, which is a visually lossless video over IP system with an encoder and decoder. That's some pretty unique features. We'll talk about that more a bit later on as well. And then about control, yeah, that is integrated into the core. So you nowadays buy a pair of licenses, one for enabling of scripting and another for the enablement of UCIs, as we call them, user controlled interfaces. So we're offering a range of various PoE touchscreens, but also iOS and Windows clients, and most recently a browser-based control option. And it's a really simple programming interface compared to some of the other products that I've seen other guys trying to program, which are certainly not easy to use. The beauty of this all is because it's all network-based, we can put this all onto an existing corporate network, and our protocols are quite well documented for IT people to implement and quite network friendly as well. So yeah, these are the kind of outcomes that we're trying to achieve with the Q-SYS ecosystem. So it's a really simple design and integration to save time, and also software based. Real-time system-wide monitoring, which we'll talk about in a minute. So we offer a cloud-based product called Q-SYS Reflect that allows us to monitor all the peripherals on any network, which is quite useful, especially if you're doing managed services with the client. We have a single platform, which obviously saves on third parties that need to be involved in a specific systems integration, and the hardware is really scalable and it's quite cost effective as well if you consider that. So a couple of case studies where Q-SYS has been implemented recently. So all the way from large sports facilities to corporates, education. Locally, we have a number of big, worship and hospitality references as well. But yeah, basically the core markets that QSC are focusing on are corporate AV, hospitality, transportation, government. We actually have a really neat project that's enabled by Q-SYS going on at the moment. We were just talking about it before this meeting started. Theme parks, which is a traditional market for QSC. So Q-SYS runs more or less 70, I think 80% of all the theme parks in the world, including, Disneyland and all of that sort of stuff. There's even in Q-SYS Designer a specific Disney mode that you can enable for features that were specifically developed for their applications. And then education. So yeah, quite a wide range of products. And then I think the post-COVID era, especially for companies like us who have large, focus on live events market, there's a lot of opportunities that will still exist in a number of these key verticals. So yeah, with that, I think I'm going to hand over to Emsia in Namibia, and he's going to take us through some of these things from a more product technical perspective. So yeah, Emsia, over to you.
Okay, thank you, Nathan. We're going to look at a few examples. We'll start with a conference example, conference room. Single meeting room, and we'll cover some of the products over the next few slides. As Nathan said, we'll always need a Q-SYS core in the Q-SYS environment. So we've got the Core 110F, which is the unified processor. There's also previous models that the 250 and the 500 was also great units. They just had card slots, and you had to buy either input cards or output cards or Dante cards, or whatever you wanted. So a very flexible system, but obviously you had to specify what you need, and you needed to design it before the time. The Core 110F is called the unified core. Basically, it's got everything that you need built into it out of the box. If we look at the back of the Core 110F, so we'll see 8 mic line inputs on the left-hand side. Then we've got the green connectors, the Phoenix connectors, the 8 line outputs. And then in the middle, we've got 8 flex interfaces. So these can be set as either inputs or outputs in any combination of them. So you can have 1 in, 7 out, however you like it. And this can even be changed on, you can add a button in your design. So for whichever reason, you can change it while in a live environment. You don't have to choose it by bulk presets while you're doing your setup. So there's loads of flexibility with that, which means you've got anything from 8 to 16 inputs, and then you have to sacrifice obviously the flex channels between in and out if you want more outputs. Looking on the other side, we've got the GPI interface where you can connect switches, LEDs, potentiometers, etc. A POTS interface, plain old telephone system. You can load on the Core 110F. You can load 4 soft phones, so you can actually make phone calls using the Core 110F. RS-232 port for third-party control, USB bridging, which will present a webcam to the PC, which means you can present any Q-SYS camera on the network, and any audio channels in the Q-SYS environment you can present to the PC via USB connection. And then the 2 LAN ports, LAN A and LAN B, for the QLAN environment. This gives you 128 channels, audio channels in, 128 audio channels out on the QLAN network, which is quite a lot for a product in this class. This, combined with all the DSP power in it, will also allow us to do a centralized system, which we'll look at a bit later on. So let's look at a few of that, or amplifier for the output. So the SPA series of amplifiers are perfectly complement to the Core 110F. It actually almost looks like a Core 110F, just cut in half. So it was made for smaller spaces in mind. You can mount these under the table or still in the rack. It's perfect for conference rooms. You can mount it on a wall, under the table, close to your laptop, or close to the speakers, depending on your situation, in the ceiling. And all hardware, mounting hardware is included. You don't have to purchase that separately. The SPA is also a Class D amplifier. It's fanless, so therefore it's silent, and still very cool. Although it's an analog amplifier, doesn't mean it's not flexible. There's multiple power configurations that you can do with it. So if I just quickly, we look at the SPA series. So if any 2 channels that if you bridge that out, you go to a low impedance 100-volt system. And so you've got the SPA2, which will be 2 60 watt channels. SPA2 200, which will give you 200 watts per channel into a 4.8 ohm load. And as I said, if you bridge them, you get a 100-volt output So you can get 200 watts into 100 volt line. So this is a key feature, especially for the SPA4 series amplifiers. So also in the example we'll go through just now, you can take one single SPA4 amplifier and have that run your ceiling speakers as well as surface speakers for your left and right channels on low impedance mode. It's not a network amplifier. It's just got analog in and out. But as you can see already, it's quite flexible in what you can do with it. To connect to the amplifier, there's speakers that they have. Nathan mentioned some of the speakers in the range. Acoustic coverage, which is the more cost-effective speakers, fairly low power installation speakers, and then acoustic design, which is the flagship, and then there's acoustic performance, line arrays, and live sound speakers as well. In this examples, we'll focus on the acoustic design speakers. These are the flagship premium range of the installation speakers, and there's a lot of features to make it easier for installation, perfect for our meeting rooms. The acoustic design speakers actually look quite nice, and they've got no big bold logos on the front. They can be painted. They're basically designed to be unobtrusive and to blend in architecturally. They're available in various sizes as well, and it's quite easy to design your system with it, integrating into the Q-SYS environment with all the tools available on the website. The ease information and 2D models and things like that is also available from the website. Installation is made easy with features such as a magnetic roll, so you don't have the stress like this guy on the right hand side struggling to get the speaker in and not to drop anything on the floor while mounting it. So for designers and consultants, there's it's easy to design also with the acoustic design speakers. As I said, you get the ease information, 2D and 3D models, voicings that you can get with that. The voicing is also built in, or the Q-SYS environment knows the limitations of the speaker or the specifications of the speaker. The DSP will know things like the voice call diameter, whether it's got a compression driver or the soft dome tweeter, etc. And then this can be used to determine the limiting if you use the right amplifier in your system. They're also mix and match capable. So all of the surface and seating pendant speakers has got a very consistent sound. So when you're moving around in a venue where you might have different speakers playing audio, you will have a very consistent and nice sounding experience from the acoustic design speakers. They also have features such as DMT, directivity match transition, which is normally found in studio monitors. Q-SYS has included this in the whole acoustic design range, which basically considers the off-axis coverage as equally important to the on-axis. So whether you listen to these on or off-axis, they will sound quite great or quite good. Naming of the speakers, distinguishing between them, AD is acoustic design. C for ceiling, 4 is the 4-inch or the 6-inch. T is it's got a transformer, and then obviously the color white or black. You'll also see that you've got the LP range, which is the low profile range. The backhand of the speakers assists or helps with the low frequency response, but in some ceilings you physically don't have the space. So to cover that scenario, there's the LP series, which they've lowered the canister at the back, but they've widened it. So the 4-inch LP range is basically as wide as the 6-inch. This gives them more or less the same cabinet volume, and they do sound very similar. You also see there's some pendant speakers available as well, and yeah, there's lots of more speakers available in the Q-SYS range. You can have a look on the website or contact one of the sales representatives at Stage Early Works. Some of the surface speakers available also in 4, 6, 8, 10, and 12-inch. 4-inch and the 6-inch have got soft dome tweeters, which is very hi-fi and musical. They can go still quite loud, but then the larger ones, the 8, 10, 12 has got compression drivers to give you even more output level for nice performance. There's column speakers as well. So the 8-way and 16-way, if you need more vertical directivity. Then there's also a baby 4-driver version of that. And then in various ranges, there's also subwoofers for ceilings, surface, and pendant subwoofers. That's also available from Q-SYS. Acoustic coverage, Nathan mentioned, is the cheaper range or the more cost-effective range. So that's when your high fidelity, high quality sound is not as important, or where your IP rating is also not crucial. So the acoustic design has got an IP rating of IP54, the ingress protection, and the acoustic coverage has got an IP rating of 44. Features such as the DMT and magnetic roll is not included, and the output is not as high as the acoustic design. There's also quite a range of surface and ceiling models available, so you can have a look at those as well. The next, we'll look at the AV USB bridging. This is basically built into the Q-SYS design. It's more than just these two products here that as you'll see just now. It will solve many of the problems in our installation in our meeting rooms. So let's talk how that's going to happen. We know by now that we need a Q-SYS core in our environment. And traditionally, in many cases, third-party USB and/or HDMI solutions are implemented to enable soft clients for video conferencing. Soft codecs are becoming more popular. A few examples shown here, and yeah, this is probably the future of video conferencing. The problem is that the AV industry uses these connections in ways that they're not really designed for. Both USB and HDMI has got length limitations, and they are designed to be one-to-one connections, point-to-point connections. Normally, they can't be terminated on site. This also causes headaches for the purchasing department and the commissioners. And despite the length limitation, you might want to add some adapters in your cable, and that will just reduce your effective length even more, because you'll get interference and signal losses. For USB, you might need active extenders, USB hubs, USB switches, and all of these can just basically become a point of failure in your system. It's not really a problem in a small huddle room. We can make it work in some of the bigger spaces, but you can't really scale this well upwards. And the cost and time that goes into this is quite high for the less integrated solutions. We might also need HDMI matrix switches if you've got multiple cameras that we're going to use to switch between multiple PCs. This just adds more costs and some more points of failure. So looking at this example here, it's a small room. Shouldn't be a problem. There's one extender for the USB webcam, USB audio to the PC, to the room PC. That goes to the PC via USB, and this is fine. But as soon as we need to scale this up, we can possibly run into problems. If we do bring your own device scenario, we want to present one single cable to your laptop. So you need a hub, which is possibly another point of failure. You possibly need another USB extender. This can also fail or not work as reliable. And these can just be frustrations that could be presented. If we need two endpoints, so we've got your rack mount PC and you'll bring your own device, you'll need to add a USB switch in there as well. And very often installers will add cheap plastic switches, hubs, and extenders. And the whole system actually really depends on what's often the cheapest part. USB wasn't designed to be used in this way, and will probably work sometimes, but really it's not the most reliable solution that can be presented. So we've got possible points of failure. So what if we want multiple cameras? The whole paradigm falls apart if we want to switch between cameras. So now we won't use USB, we'll go to an HDMI solution. This might be a VIP meeting room with multiple camera angles for different scenarios. For this, we'll probably make use of PTZ, pan-tilt zoom cameras, so we don't have to add even more cameras. So let's say we want to add 3 cameras. All of them will need power. They need to be controlled. And obviously the video feed is another cable that needs to be installed. And this just adds to a lot of installation time. Some TX and RX transmitters for HDBaseT. As we know, HDMI has got a length limitation, which is actually quite short if you start going in meeting rooms up the wall into the cabinet. And this just adds more black boxes that adds costs to your design. Adding DSP to it and control, it becomes quite a big system. So there's a lot of technical or tech in this for a fairly simple solution that needs to be done. Quite a big shopping list as well. So let's look at the same solution in Q-SYS. There is normally a network point or network system in the room or in the building, and we'll work on this. Q-SYS makes use of gigabit networks. Standard gigabit networks is fine for Q-SYS. So you just need PoE ports for some of the devices. Network, the advantage of network, it's not necessarily point-to-point. Cat5 cable has got a limit of 100 meters, which is much more than USB and HDMI. Without the need of any extenders, you can terminate in field. Yeah, you can basically scale this the way you want it. So we need to, in our environment, we'll add the Q-SYS core. Remember at the back of the core, there was a USB port. So the Q-SYS core and the rack mount computer is close to each other. So we've got a short USB cable running to the computer. And this is what USB was designed for, short cables and single one-to-one connections. The core will then present a driverless webcam to the PC and also audio device. It will present itself as an echo cancelling USB speakerphone if it was chosen as such in the design, and then a USB webcam. Any audio in the Q-SYS environment in the Q-SYS can be presented to this PC. And also, if we add cameras, we can present any Q-SYS PTZ camera to the webcam feed. The Q-SYS camera is also PTZ, but it's network-based, which means there's one cable instead of three. So video control and power happens via one cable over your standard network cable. As we said, relatively inexpensive, easy to handle. You can buy a big roll, a 500-meter roll of cable, cut it to length on site, terminate it, and you sort it. It's much easier to design, and yeah, as I mentioned, it's just one cable that you need to this PTZ camera for control, video, and power. Controlling the system, all you need to do is add a touch panel. Once again, one inexpensive network cable. You don't need a separate control system for this. The core is the control system. Just add the panel to the network and you can set it up. If you want to add more cameras, no big story. Make sure your network switch has enough ports, can supply PoE to the cameras, standard PoE, and you can add as many cameras as you need. If you've got all these multiple cameras, the core system can switch between any of the cameras and present that to the PC. And the PC will just see one USB device. There's no USB switching, so there's no sync issues when you're switching between devices, cameras, and audio sources. Adding more endpoints. So we had a rack mount or built-in room PC. Now we want to employ BYOD, bring your own device. So at the laptop, for that, all we need is the Q-SYS IO USB bridge. Install that underneath the table, close to the cable copy position. Short USB cable that comes out that you can plug into your laptop, and then a longer network cable that runs into to your network switch. Once again, one cable, no issues. So the bridge will also connect to the laptop with the USB cable, as I said. And the bridge also presents itself as a webcam with echo cancelling speakerphone to the laptop. And then any of the cameras and audio sources can be routed to the rack mount PC or the laptop as required. You can add many cameras and multiple USB IO bridges to the system. All you really need to consider is how many ports you have available on your switch. And if you run into the limitations there, it's actually quite easy to sort that out to get more points available. In Q-SYS Designer, for those of you that's worked with it, adding, routing, and controlling camera feeds and USB video bridges is exactly the same as you would do with audio. For audio, we route audio sources through switches or mixers to speakers. For the video side, we route cameras through switches to USB bridges. Fairly simple to do that. The Q-SYS camera, there's two models available, 12x72, 12x60. It also, in addition to the network feed, it also sends out the SDI, 3G SDI video feed and HDMI video if you need to use that as well. The bridge that we spoke about, PoE powered, as we said, connected to close to the laptop, to your BYOD device, short USB cable, no fuss, no issues, stable solution. So let's look at a quick design exercise using the products that we spoke about. So the client spec says he's got a 10-seater meeting room. He's got a PC fixed in the room, rack mount PC, but he also wants to be able to present from the table. He wants high quality table mount microphones. The room will be used for meetings, VoIP calls, presentations, and VC calls. And the cameras are required for the VC, and he wants to capture it from multiple angles. Quite straightforward requirements, but they do require multiple cameras, which can present an issue with traditional systems. Turning this into a Q-SYS design is quite straightforward. The bill of materials will not be that large. We'll use the Core 110F for this, for the audio DSP. Multiple cameras is straightforward without any extra infrastructure added. Just add the cameras, USB bridges if needed to the switch, and we're good to go. Looking at speakers, we've got ceiling mount speakers and surface speakers that they want. So remember we said on the SPA series, you can bridge a channel and it converts to 100-volt system. So we'll use a SPA4 amplifier in this scenario. One pair of channels for the 100-volt system for ceiling speakers, and then another pair for your surface speakers for your left and right signal. Once again, we'll look at the acoustic design, a range of speakers. Acoustic coverage is also option. Specific model will depend on the room size and requirements regarding that, finer details. For control, we don't need to add a controller. Control is done on the core. We only need to add the touch panel, and then we sort it. For video, multiple camera angles, feed it to the in-room PC, and you'll bring your own device. So we'll add multiple PTZ cameras to the core's USB point can be connected to the room PC, and the USB I/O bridge can be added to connect to the laptop or under the table. So let's build our system. So our Core 110F connects to our network switch. We've got 10 microphones. So we've got 8 mic line inputs. And if you remember those flex channels, so 2 of these will be set as inputs. So we've got 10 input channels. We'll use 3 of the output channels, as we discussed just now. Cameras, let's just add 4 cameras. That should be enough for this, for covering quite a large room. And whether you add 1 camera or 4 cameras or 10 cameras, the only thing that needs to change is the network switch. The USB bridge to present to your laptop for the guest, and then the core's USB port will be presented to the rack mount PC. In this design, we just use the HDMI signal straight from the rack mount PC and the laptop that will go into a HDMI switcher. This can be controlled via RS-232. So we've got 1 port on the I/O bridge. We've got 1 port on the core. So these 2 can then be used to control the systems. So, and then we'll add the touch panel to our design. Once again, just connect that to the network, and we've got our system. So in summary, we've got a 4x2 video matrix. We've got 10 acoustic echo cancellation processors, and then we've got a control system that's available. So client's happy, installationist team is happy. This is going to be fairly easy. So we are happy. So let's look at the limitations of the Core 110F. We can see there's lots of analog inputs and outputs, a huge amount of network audio. There's 16 audio players built into the Core 110F, so you can do multiple tracks, background music. You can load 4 soft phones. And the Core 110F has only got 16 AEC channels. So in a conferencing system, this is probably the first limitation that we'll run into. So let's look at a solution with more microphones. In our previous design, we used 10 channels of audio echo cancellation. You can see that this will be the first limitation that we'll run into, as the other figures are quite high. So now we just replaced the microphones, the 10 microphones, with 2 ceiling mics, 2 8-channel ceiling mics. These are AES67 compatible, so they'll connect to the switch for audio control and power. All core network channels, or Q-SYS core channels, are AES67 compatible. And as Nathan said, the native Dante has also been added now. It's just the license features. In this installation, we'll use all 16 channels of echo cancellation, as we need one echo canceller per microphone. And we've got 18 audio channels, one in and one out from the bridge for your laptop. Fortunately, we've got 128 channels available, so that's not an issue for us. In this instance, we've changed the control of the display over LAN, so you can control that. So how far can we push the core microphone, the core 110F? The next limitation that we must look at is the network audio channels. In our design so far, we've been very far. We've got 128 channels of QLAN or AES67. So remember how powerful this core is. Although you have the limit of the 16 channels of echo cancellation, you can still do plenty of your normal bread and butter installations with standard DSP. If we have a core somewhere in the building, there's lots of IOs that you can send output audio streams that you can send to the core from various endpoints, and then have that managed. Because the core is so much more powerful than its competitors in the range, DSP processing is not an issue for that. You don't need multiple DSP processors for distributed system. You only need the one core. So let's build up a bigger system in a very cool and trendy environment or venue. We've got a building with 2 meeting rooms and auditoriums. We've got the 16 echo cancelling channels being used up in the meeting rooms, but there's still plenty of DSP left for EQing, mixing, routing, dynamic processing, all of that. So we've got some in our auditoriums. We've got some AES67 mixing decks in the auditoriums, and then we'll add an IO8 Flex for IO expansion in all of the rooms. We'll have a look at the IO8 Flex just now. We also have a background paging system, background music system, with plenty of inputs and outputs, and even a cinema. This is quite a nifty venue. All of this can be done with single core. For the paging system and for the cinema, we use network amplifiers. So they've got additional inputs on the amplifier itself, which can be presented in the Q-SYS LAN, in the QLAN environment, so they can be used anywhere. They're not specific for the amplifier. It's just an input, analog input. You can connect a microphone or a playback source, anything to that, and present that to the core. If we add all of these inputs and outputs, it gets a lot, but we've got 48 inputs, 68 outputs, but we still have 80 inputs left and 60 outputs left. So still we're quite far from limitations. So this was a centralized system, basically, that we looked at. So let's quickly look at some of the peripherals that we used, the IO8 Flex, and then Q-SYS control that we spoke about. So in our design, we had these IO8 Flex units in our rooms. So it's got 8 ports that you can use either as inputs or outputs. The core is somewhere else. It's not in one of the rooms. It's somewhere in the server room, and it can manage all of these channels. And that's what the centralized system is all about. We don't need processors in each room. So just our network channels, same story. We've got enough processing power available. The IO8 Flex, let's look a bit more closer at it. It's a Q-SYS peripheral, and this looks almost also similar to the Q-SYS core, just cut in half. But obviously there's no DSP processing in this. It's just the inputs and outputs. Let's quickly look at the rear panel. We've got the 8 Flex channels, same story. You can configure them as inputs or outputs as needed in any combination. This is done in the software, so no hardware changes. This can be put in any room and handle your audio input and outputs. These channels will then connect to the core via the QLAN network. GPIOs to control shades, LEDs, get occupancy sensors, and RS-232 for local control. And then USB B port for audio bridging. Take note that this is only audio. There's no video bridging on the IO8. This is an audio only device. Single cable powered by PoE. This is a PoE Plus device. It's important to note that the IOFlex is not a standalone box. It's still part of the Q-SYS LAN. You don't need separate software, anything to control this. It's still a centralized design that you're running from. Q-SYS peripherals, unlike third-party devices that could require separate software to program and to control it, the Q-SYS peripherals is in the same environment. You can see all details with it. You control it from one device. You program it from one point. The programmer only interacts with one device on the network, which is the Q-SYS core, and that handles the rest of the peripherals. When you deploy your design, all the peripherals gets programmed, and if there's firmware updates that needs to be done, this will also be done if needed. To go along with our system, we need a control system, control interface. Looking at Q-SYS controller bit, it's quite powerful to scale this up. You just scale your design, add your UCI or update your UCI, and there's multiple layers and pages that you can interact with on a single touchscreen. And there's no additional cost if you add more features to your design, hardware cost, using a single touch panel. Looking at traditional hardware-based control systems, we have control processors, audio processors, and lots of other devices which needs to be controlled. And very often this might use different programming tools and applications. There's lots of links between all the equipment, and it should work most of the time fairly fine. But scaling this up, controlling cameras, becomes a bit more tricky. It's doable, but it's not as easy. However, when we scale this up, as I said, this becomes a challenge for us. Just doing a firmware update could be quite some effort if you've got separate control systems, separate interfaces that you need to connect to separately, and then bump your updates to it. If a logo is needed, a logo change is needed on the design or on your interfaces, it can be quite a challenging task. Doing this in Q-SYS is quite easy. Making global changes is fairly easy. You're interfacing with one device, your core, and that speaks to the rest of the network, the rest of the devices on the network. Audio processing in general is quite difficult for computer, as there's a lot of information that's time critical. But fortunately, as we've seen, the Q-SYS device has got loads of processing power available. But apart from that, control is not as difficult. Control is easy. There's not too many processing power, so much processing power required. So that's why we can use the core, a single core, to do multiple control systems. There's also no real practical limit to how much control can be done from a central or from a single Q-SYS core device. You can even run your building from maybe one of the larger cores, the 510 or the 5200. If you want to add more rooms in your system, just add the endpoints, update your design file, and that's it. It's so much easier and to scale and much more cost effective. On your touchscreen, you've got you need the UCI editor. The UCI editor is used to build your touchscreen interface, but it's not a separate application. It's just a licensing feature that you add to the core, and you can build your UCI and dump that onto your touchscreen. It's all of it is done inside Q-SYS Designer. The same for scripting engines. If you need to script for control, it's a license that you add onto your device, onto your core, and you can do quite complex scripting if needed. If you're interested in more into this, there's you can contact one of the Stage AudioWorks representatives. There's very good Q-SYS training modules also available on this.
MC,
Yes.
Don't want to interrupt, but there's a lot of questions coming in about licensing, so I thought I'll just explain that quickly.
Yes. Okay. Sure.
There are essentially 5 different licensed features in Q-SYS. 4 of them are perpetual, so you would buy them once and that would last for the lifetime of the product, and that's linked to the core itself. And then the last one is the software as a service product. So the 4 different licenses are obviously the UCI editor, which you would need to deploy any UCI on any device. So if you buy a touchscreen and a core, you need to buy a UCI editor license. The second license obviously is the scripting license, which allows you to run scripting inside the core. Now, this is also needed most of the time when you have a touchscreen. However, if your touchscreen is just doing audio only control and you're not controlling any external stuff, or you don't need any detailed external control, then you don't need the scripting license. But usually when you specify a core for a project and you're using the core to do control, I would recommend that you specify it with both a UCI and a scripting license. The third license, which has just come out now, is obviously the Dante licensing. Now, the Core 110 comes with 8 in and 8 out for free for all new cores from the 1st of May, I believe. Obviously, QSC is paying ordinator license fee per core, so that license is not grandfathered, as they call it, to previous cores. So we have an 8x8 Dante license you can buy if you've already got a core in a project and you want to add the Dante functionality. However, if you buy a Core 110 today, you'll get 8x8 audio included. The fourth license is about multi-track playback. So we spoke earlier that the core has a multi-track audio player inside. It can play with no license 16 channels of audio at the same time. However, if you need more than that, there are various license 32, 64, and 128. And then the last license is the Q-SYS Reflect, which is a monthly fee that you pay for that service. So I hope that clarifies it. And then, well, yeah, we'll come back to Alan's question in a minute.
So designing your UCI, all your aspects, all your items are in your Q-SYS designer schematics, and we can just drag and drop those items onto your UCI, arrange them accordingly as you like, and you've got your control on the touch panel from one interface. Also note that you can add custom logos, you can add custom buttons, you can apply CSS styles, all of that on the touch panel. On the side of the scripting, Q-SYS makes use of open source scripting language called Lua. Lua is quite fairly easy to learn, and there's loads of YouTube tutorials available for this. It's not a Q-SYS scripting language by itself. This is great for third-party control or writing any type of program inside Q-SYS. You'll want to use Lua. You also have third-party plugins that's also available. This is a ever-expanding list that you can get in the asset manager. For some of these plugins, it's as easy as typing in the address, the IP address of your device, and you've got full control of it. The asset or the plugins from the asset manager is supported by Q-SYS, so they're either written by Q-SYS or by the third-party manufacturer and then signed off by Q-SYS. There are also plugins available online that you can get from other people. Obviously, these are not natively or not supported from Q-SYS as a support aspect, but you can definitely use them also on your core. The last feature on the scripting side that's available is the block controller. The block controller is there to make scripting and controlling much easier. Basically, if you understand the logic of what you want to achieve, you don't need programming experience. Drag and drop your modules, your blocks inside it, configure details, type in there, and you've got quite a powerful and flexible scripting feature. Looking at our touch panels, we need a way to get the UCIs onto a screen. There's also a few different options. You can use an iPad, Windows clients, and then also there's HTML5 UCI viewer, which will be available through a browser. And then of course Q-SYS a range of touch panels. These are the second generation touch panels, the TSC55, TSC80, and the TSC116, which is 5.5 inch, 8 inch, and 11.6 inch. The 8 inch and 11 inch also have a table mount option, and all of the models can be wall mounted. Same as the previous devices. Since this is a Q-SYS peripheral, the same philosophy applies. You don't program this panel separately. Everything is done from Q-SYS Designer. You create your UCI, you add the touch panel in the inventory list, and then you just tell your UCI where it needs to be displayed, and that's it. As I said before, if there's a firmware update for it as well, that will also be handled by the Q-SYS Designer. If you deploy your design to it, if you've got your touch panel and it gets broken or somebody spills coffee over it, something like that, there's no reprogramming that needs to be done on the panel. Take out the damaged panel, put back the new panel, set the name for it, and then just apply your program again. There's also no real limit of the number of UCIs that you can have in your design. So you can have multiple user-controlled interfaces in your design. So we'll look at a design exercise quickly as well for centralized system. So we have an understanding how to remotely expand our audio and control. So we're building the centralized design. The client spec is now asking for the single room design that would be deployed 4 times, so 4 copies of the same room on a single floor. And we can think this can probably be done from a core, but not 1 core per room. We can probably do this with 1 core for the entire floor, for all rooms. So if you have 1 core, we need to look at the limitations. So what we've seen is we've got 16 AEC channels. So our client wants surface mount microphones as well. So it's a 6-seater, so we can probably get away with 4 microphones per room. Network audio channels, you can work it out, but there's more than enough. We've got 128 in and out on the 110F, so we don't need to worry about that. Analog inputs and outputs, we can add the IO8 flex, 1 IO8 flex in each room. So that gives us 4 inputs, or what we'll need is 4 inputs for the microphones, and then 3 outputs for the speakers, which is 7 channels, which is okay. We've got 8 on the IO8 flex. Control, all we need for each room is a touch panel, 4 touch panels that goes to the Q-SYS core, which is not an issue. Just take note that you'll need a UCI license in this design. And then if there's third-party device that needs to be controlled, the scripting license needs to be added as well. So this is very similar to our previous design, except that the IO8 flex has replaced the core in the room. So we're not using the core, there's the IO8 flex in each room. And then we've got the camera, the touch panel, display device, USB bridge, amplifying speakers, and then the core somewhere else in the network, in a cabinet in the hallway or somewhere. All of this is done from a single interface. There's no multiple devices that needs to be programmed. Deployment, updates, maintenance, all of that is then easy and straightforward. So that's all from my side. I'll hand back to Nathan for the larger systems.
Cool. I'll just answer these questions while we're at it here. So JP asks, how's the security of the conferencing units? So from our perspective, we're handing over a USB signal into a PC. So the security is a functionality of your soft codec. So be it Zoom or Skype for business or Teams or whatever it is you guys are using. So it is as secure as a webcam would be. So from that perspective, think about the Q-SYS room system as a glorified webcam and speakerphone. We have no security exposed, internet exposed elements on our system. And then Alan asks, can we use any PTZ brand camera or only Q-SYS? So we can control other PTZ cameras, but we can't use other PTZ cameras to do our IP bridging. So if you wanted to apply that system that MC showed, you would have to do this with the Q-SYS PTZ cameras. So I know that's kind of expensive, but it's necessary because obviously we're outputting IP video, not baseband. So let's quickly have a look at the large stuff. All right, so obviously MC has shown you a centralized system with the core 110, but what if our project is much larger than, you know, a 2 or 3 meeting room type of project? So this is when we would consider switching up to like a bigger processor like a core 510. It's not just about being more powerful than a core 110. The core 510 is definitely the most configurable Q-SYS core. So the major difference between the core 110 and the core 510 is that the core 110 has no fixed input and output configuration on the back of it. So we're using cards, which are available, and you could configure the IO on the back of the core to be however you wanted it to be. So you have 8 slots, so this could have 8 different cards inside. And these are the various options that we have. We have an analog mic line in card. actually two versions of that, one standard and one high performance. The difference is that the microphone preamps on the high performance are a lot more, or a lot lower noise. And the main application for this is for ambient noise compensation mics when you have a very, very long 100, 200 meter microphone cable coming back to a control room, and you need the ultimate performance on the analog side. Then obviously we have the line out. And then we have a AES EBU, which is a digital standard that's most commonly used in live sound, with 4 ins and 4 outs per card. So that allows for interfacing with, like in our world, maybe a D&D amplifier or something like that. Then you have a 16-in AES card. That card is commonly used in cinema applications because a DCP player or a media block in a projector usually has, 7.1 feed or bit stream, they call it, that comes out on a Cat5 cable. This is just AES. So we have a card that allows us to natively collect or connect the media block of a digital cinema projector into a Q-SYS core. Then we have a POTS card. This is quite new, but you have 4 POTS lines. For those who are new to this, POTS stands for plain old telephone system. So this is really used for interfacing with legacy telephone systems, which are still quite common here. The trend globally is to move to IP telephony. So even internally in Stage Audio Works for 5-6 years already now, we've had no analog phone lines. Everything comes in over our internet connection. But there are still a lot of large corporates, banks, whatever, that are still using massive analog telephone systems just because it's a nightmare to replace them. So we can interface that. Then we have a Dante bridge card. This is becoming less relevant with the launch of the software Dante. But the one benefit of having the Dante bridge card is that you can have a separate Ethernet ports for the Dante network if that was a requirement. So in some applications, like maybe a large theater where there was a lot of Dante devices, as well as this totally separate QLAN network, you could have separate physical Ethernet networks for those 2 different protocols. That's a relatively advanced configuration. If you wanted to chat about that, I'll give you a call outside of this. And then the last card we have is an AVB card. So AVB is an open source network standard based on an IEEE standard called TSN, time sensitive networking. It's a layer 2 Ethernet standard, and it's used by a couple of manufacturers, most notably like Avid, Mayer Sound, D&D, Acoustics. A couple of these companies are getting onto AVB stuff because it's able to guarantee a very, very low latency. So of course, Q-SYS as a platform should support everything, and we do. So if you wanted to use AVB, you would need a separate physical card to do that. So looking at the back of the Core 510, you can see our 8 card slots that's populated at the moment with, you can see 8 mic line ins, 8 line outs, and a Dante card. Then in the middle, we have GPIO. The Core 510 has more flexible GPIO than the Core 110. We have some NC/NO relays. All of the Q-SYS GPIO is incredibly configurable. So this is, if I've worked with some other DSP platforms and the GPIO configuration is quite limited, but the Q-SYS GPIO is really, really flexible. You can connect anything to any port and it just works. Then we have a legacy RS-232 port. And the big difference from a network perspective on a Core 510 is you have 3 Ethernet jacks and not just 2. So we have our main and redundant QLAN ports. We call them QLAN A and QLAN B. In addition to that, on the Core 510, we have what we call an aux LAN. So this is an additional network port that you can use to interface this core with a corporate network or with the control network, for example. So in some applications, you might want to isolate the real-time audio traffic into a different VLAN from the control traffic. So the Q-SYS core, for those who are interested, doesn't support VLAN tagging on the ports. So we have a separate physical NIC that allows you to bridge a Core 510 into a separate control network. Again, the processing headroom situation is kind of ridiculous with the Core 510. In terms of DSP, it's roughly 5 or 10 times more powerful than a Core 110. And the numbers are quite startling. So compared to a Core 110, one of the biggest major differences is that we have the ability to run up to 64 AEC processors. So as we saw with the Core 110, this is the major limitation with centralized systems is the amount of AEC that we can do. I have an application example about a Core 110. Actually, we won a contract a couple of years ago to renovate the background music system in Grand West Casino in Cape Town. And there's 70 zones of background music, and that's actually all happening on the Core 110. So it shows you that even for a very large system, if it's audio only, there's plenty audio processing horsepower in even our smallest core. But the acoustic echo cancellation is a really CPU intensive process. We'll talk more about AEC. There was a question about that at the end of this presentation, but basically the Core 510 has a much more powerful processor inside, and therefore we can run a lot, 4 times the amount of AEC processors. We also have double the network IO, and also 64 VoIP instances. So in the Core 110, you can have 4 soft phones connected to a SIP server like a Cisco Call Manager or Asterisk or whatever it is. But with the Core 510, this can be scaled up to 64. So even for a very large teleconferencing application. So typical of a large scale system, we also need multi-channel amplifiers. So we spoke briefly about the CXDQs, or CXQs rather. And this shows the legacy of Q-SYS power amplifier design. So we have a really well-designed power amplifier circuit. It's integrated into the Q-SYS environment. We have this function called fast, which we'll explain in a minute. Then we have some interesting input options. So let's talk about fast firstly. Historically, amplifiers had a fixed power output per channel. So especially in corporate applications or cinema applications where you needed really different power output ratings per channel, it was quite inefficient because you would then have to have multiple types of amplifiers. So what fast is, it introduces this concept called flex amp, where you can dynamically assign the amount of power available on a channel by channel basis. So this allows for a really flexible use of a single amplifier. You can see an example here where you would have maybe a higher output or higher power requirement for a subwoofer, for example, on one channel or a pair of channels that can be run in parallel, not necessarily in bridged. That increases the power voltage rather than the output current, which is quite helpful, especially for driving big subwoofer drivers. And then a mixture of low impedance and high impedance 70, 100 volt line loads on a single amplifier. So you can see that that's a really flexible tool. So instead of having multiple types of amplifiers to run one system, you could replace all of them with a single amplifier. There's a number of different models in that series, and they're available in 4 and 8 channels. So we've done projects with just a single 8-channel amplifier driving, multiple. You could even drive like, we have an installation in the school, I think, where we have 1 and 8-channel amplifier driving an entire surround sound system in a classroom. So it's a really flexible product. Then we have 2 variations. We have the CXQ and then CXQN. The CXQ has some analog inputs on the back, but these are not inputs for the amplifier. These are actually network audio on-ramps. So these audio channels are available anywhere in the Q-SYS network. So that application we spoke about earlier with ambient noise compensation mics, if you had an amp rack on the far side of a shopping mall or something, you could actually connect those microphones to a local amplifier if those were located in a local rack and connected via network back to the core, and shorten the analog run. So that's an incredibly flexible tool. So we have a big installation that we spoke about last week in Dubai, for example. And there we have a Core 500 with actually no cards. All of the I/O is handled by amplifiers in the various zones. So it provides a really easy way to integrate analog I/O, especially in a centralized design. So apart from that, our amplifiers, our loudspeakers support this thing called intrinsic correction, which is basically a DSP set for the QSE loudspeakers. And the amplifiers, CXQ amplifier supports some DSP offloading. So when you have a design that contains QSE loudspeakers with intrinsic correction, the core is able to offload the DSP processing onto the amplifier itself, which frees up some of the processing resources in the core, although most of the time you still have plenty headroom. And then apart from that, we have really deep control and monitoring of these amplifiers. We can see impedance, temperature, fan speed, input voltage, output voltage, all of that sort of stuff within Q-SYS Designer, which makes it quite helpful, especially on a large system where your amplifiers might be distributed over, a casino campus or the large theme park or something like this. So the next piece of equipment that's particularly relevant for a large-scale system is our NV series, which is our new network video endpoint. So native video distribution really, simplifies things, because again, we're able to bring control and audio alongside the video into a single pane of glass. So we have a single SKU. So unlike our competitors that have separate encoders and decoders, we only have one box that can be defined as either an encoder or a decoder. And we have a new codec technology. So compared to a protocol or a codec like JPEG 2000, which has a constant load on your network, we have a codec that we use called Shift. It was developed by Q-SYS for this product, which basically allows for what they call adaptive bitrate compression. So if you have a lot of static content on your screen, it lowers the network bandwidth for those moments. Obviously, if you have fast motion video content, it increases its network utilization. If we consider the NV32 as an encoder, we have 3 HDMI ports on the back. Now, this can be used to encode 3 1080p 60 HDMI sources or a single 4K source with a local output. The NV32 also has a USB port, by the way, that you could use as a USB I/O bridge for the cameras. So you could install this under a boardroom table and connect your HDMI sources and USB directly to this. It also has GPIO, so if you were using push buttons for control or trying to control blinds or something, you could do this from the NV32. It also has audio inputs and outputs on a 3.5 inch or 3.5 millimeter mini jack. The other thing that's important to note is that all of the audio from all of the HDMI inputs and outputs is de-embedded or embedded and available as a network audio stream inside the Q-SYS ecosystem. So you can route this audio to an audio path inside Q-SYS and out to a pair of loudspeakers with no additional hardware. That's all managed within the video over IP solution. When you use the NV32 as a decoder, you can receive 2 streams from a network, which makes it quite helpful. A trend in especially boardroom installations right now is to have 2 plasma LCD screens at the front of the boardroom, one for the local presentation content and one for the VC far side video. So this is supported by a single box. You can mount one box behind those 2 screens and just connect them with HDMI. And the other thing that it allows is you can use it as a kind of rudimentary switcher. So local inputs can be routed to the outputs, which is quite handy. And as I already mentioned, we have the shift compression that far lower network usage, especially in moments of low motion. How to design a system like this? It's quite straightforward. We just need to add our NV32 endpoints to our network, connect them with gigabit Ethernet, and connect our displays and sources. The rest of this is already quite familiar from MCA's section. We have our audio stuff going on just like we had before. And by the way, the core itself handles no video. It only sets up routing between the endpoints directly, so it doesn't add any additional overhead apart from the audio channels into the system. And the other thing to note is that NV32 is a gigabit network-based thing compared to some of the 10 gigabit solutions out there. So it's quite manageable with lower cost networking hardware as well. Obviously, because we have this tremendous processing power in a Core 510, we can really scale this up so that a single Core 510 in the server room or something can handle many large auditorium spaces. Again, the limiting factor most of the time is the amount of AEC channels available, which is kept at 64. Let's quickly run through a design exercise of a larger system. So we have 4 meeting rooms this time and 4 boardrooms, as well as a background music system coming off this core. Each meeting room has a Dante-enabled table mic, a PTZ camera, a BYOD, and 4 ceiling mount speakers. Each of the boardrooms has 6 ceiling mount speakers, I guess, for speech reinforcement from the far end, 2 surface mount speakers for video playback, a Dante-enabled ceiling mic, like a Sennheiser Team Connect or a Shure MX910, and then 2 PTZ cameras, 2 BYODs or in-room PCs, and then 2 displays. And then the background music system, I guess, for all of the public spaces with 8 zones for control, and then an analog input for a music player. The questions we need to look at is how many NV32s do we need in each boardroom? How would we connect our analog amps? And how many amp channels do we need? And then what input cards do we need for the core, if any? If we draw up a room model of our, room A being our boardroom or our meeting room and room B being our boardroom, we can get a brief overview of the hardware needed. So our meeting room is quite similar to what MC already came up with. We have our Dante microphone, we have a touchscreen, we have our speakers and some amplifiers in the server room. In our room B, we just have our NV32 encoder under the table, our NV32 decoder that's feeding the two screens. The PC on the table is connected to the NV32 to receive the cameras. And then obviously the camera is connected to the switch as well as the ceiling mic array. This can then scale up. We can see our various meeting rooms and boardrooms now still connected to the core in the server room. And by the way, you'll notice we actually have two cores here. It's a feature we'll discuss in a minute because cores can run in a redundant mode, which is again quite a unique feature. And then you can also see our background music zones. So if we had to go back to our questions, we looked at the analog inputs. If we had to do this in the server room, we would need to add an analog card. Apart from that, all of the I/O in this room is handled over network. And if we had CXQ ends with the inputs on the back, you could actually not put a card in the core and connect your analog music source directly to this. So here's an example of a large corporate just running on essentially a single core 510 with the second one being used for a hot failover. So yeah, on that topic, let's really have a look at some principles. We spoke briefly about redundancy. Most systems don't have the budget to run, but some applications like maybe government or a theme park where you needed high availability, you can run the core or the whole Q-SYS network in a variety of redundant modes. So the first thing we can do is we can introduce core redundancy. So all we need to do is add a second core into the network and set it to redundant mode, and this will then automatically follow all of the design changes that are happening on the primary core and constantly monitor one another for their health. So they send a series of handshake messages every couple of seconds to make sure they're functioning normally. If those are unacknowledged, then the secondary core automatically assumes the role of primary, and all of the I/O peripherals will then switch over to the secondary core. And that happens depending on your I/O within a couple of seconds. The second thing we can do is we can add a totally separate network. So as I showed you before, we have a QLAN A and QLAN B ports. What's common again in high availability applications is you would have a main and redundant network switch. If you connect both of the cores on both of the ports and all of the I/O peripherals on both A and B, you could have a primary switch or network failure, and this would switch over to the secondary network, not necessarily the second core, without any audio loss. So the audio is streaming over both networks at all times. If you lose the primary network, you won't even hear a glitch in audio whatsoever. And the last thing we can do is we can actually add a secondary peripheral. So most of our I/O has relays that allow it to, isolate itself from the load. So if there was a failure in an I/O frame, for example, you could easily switch over to a backup. So you could build a Q-SYS system that's really resilient to all kinds of faults. And again, this is a pretty unique feature on the market for these kind of things. If we talk about QLAN, I already mentioned that QLAN is a protocol stack. It's not necessarily a proprietary thing of like Dante, for example, that's closed source. But the Q-SYS is, or QLAN rather, is a stack of standard IEEE protocol. So we are using a protocol for synchronization called PTPv2, which is open source and implemented by a lot of manufacturers. We're using RTP for audio transport, by extension AES67. And the beauty of these things is they're very RT friendly, so we can work on either a dedicated network or an existing corporate network. So the Grand West installation I mentioned earlier is actually running on the casino network. We don't have a dedicated network. IT created a VLAN for us, and we just pipe our QLAN audio all over the complex that way, and it works flawlessly. So you guys as integrators can configure more or less any non-proprietary Ethernet switch to work as long as it's managed and subscribes to a couple of specifications. But yeah, QSE does provide a series of switches, which is called NS series. These are actually made by Dell and running a QSE firmware with a pre-built configuration. So if your system was a centralized or a single system without a lot of switches and you were able to run your infrastructure in a dedicated way, you can actually buy NS series switches and there would be no additional configuration needed to make it work. So yeah, the beauty of buying a switch from QSE, as I mentioned, is that it's already pre-configured, so it does reduce your interaction with IT, which is sometimes painful, and it reduces overall tech support requirements. So we have 3 models: the 1108P, which has 10 ports with 2 10 gigabit SFPs for uplink. We have a 24 port and a 48 port with a PoE budget of 375, 190, and 375. So we can power most of our peripherals this way. QLAN as a protocol could use up to 86% of a gigabit link, which allows for around 512 by 512 channels on a single gigabit link. Q-SYS designs Q-SYS Designer shows a dialog box that gives you an estimated network bandwidth. But modern day networks where the entire thing is with gigabit switches and usually 10 gigabit backhaul, there's really no concern about network bandwidth in most modern networks. So we spoke already about the feature licensing, but yeah, there's just another overview there. The licensing is perpetual. As I mentioned, we have the 4 perpetual licenses now: control scripting, UCI, Dante, and then simultaneous audio. But the paging, AEC, all the network stuff, all the show control stuff is all included already. So yeah, the big news for us in recent months has been about the software-based Dante, which basically allows for a core to natively exchange Dante information with other Dante devices. This was possible before because most Dante devices these days support AES67 mode, which is a kind of an open standard audio network protocol that was created by the Audio Engineering Society. However, the one major benefit I see now for having Dante on a core is the ability to use Dante Virtual Sound Card to interface audio with PCs. But yeah, also the one disadvantage of AES67 is that in the Q-SYS context, the audio is all multicast. So you need a managed switch that can manage the multicast audio, whilst it would flood all of the ports in the VLAN. With Dante, well, if you have multicast management, that doesn't happen because of IGMP snooping. But with Dante, the audio flows are unicast by default, so it's a lot simpler to plan and implement a network for that. Yeah, I mean, apart from the core 510, we then have our very big core, which is the 5200. So just like the network switches, the core 5200 is actually a Dell server that runs a custom firmware or Linux operating system that QSE has developed. As we mentioned in the very beginning, Q-SYS in itself is actually just an Intel processor-based device. So QSE ported the firmware to run on this. There's a number of advantages to running on a standard server-grade hardware. Like enterprises are using tools like iDRAC to manage that hardware, and it has hot swappable fans and dual PSUs. Because obviously, if you were using a central core to run 80, 100 meeting rooms in a complex, you would need to make sure that that works all the time. So the hardware is a little bit more resilient than a core 510 and a core 110, but not that those are unreliable in any way. But the core, 5200 really enables, IT-centric AV design. So we can plonk this server in our server room and connect it to our building network, and it's something that IT people do understand. The core 5200 is roughly 3 or 4 times more powerful than a core 510 from its DSP processing perspective. And we have up to 160 AEC channels and 512 by 512 QLAN or AES67. So it's worth noting that because the core 5200 is essentially just a server, a PC, there's no I/O capability on board. So all of the I/O has to be over the network, be it Dante or AES67 or QLAN. This is, again, the intended application is that this core will be buried in a server room somewhere far away from all of the devices anyway. So you just have to consider that if you're designing a system that's that large. So you could see we can actually just scale up the example design that we did with the core 510 to cater for 3 or 4 times the amount. And it really is as simple as that. So again, going back to our outcomes for the Q-SYS ecosystem, what we're proposing or offering is a really simple design and integration opportunity, real-time monitoring of the entire system, a single platform, and then extreme scalability and cost saving. Cool. So that's just that was kind of all we had planned for this course. I think the purpose of the architect training is to really give you guys a kind of pre-sales introduction into what's possible with the Q-SYS platform. Another important part of Q-SYS is, of course, actually learning how to use it. And we have a very well laid out online training platform that I know a couple of guys in this chat are already working on. And you can visit qsetraining.com and complete our level 1 certification, which gives you all the necessary tools to deploy a conference type of Q-SYS system. We'll have a Q-SYS level 2 in classroom training as soon as we can open our office again for these type of events. And then also there's a Q-SYS Control 101 training that gives you insight into the various control and scripting functionality within Q-SYS Designer. So yeah, qsetraining.com. You can register for those, and you will get some InfoCom CTS points if you're chasing that as well. So any questions? Let's have a look in the chat here. And then Chris had a question earlier about AEC. He said, can you shed some light briefly on the shared reference function of the AEC component and how this connects in Q-SYS Designer? I can. So what is AEC firstly? So AEC is acoustic echo cancellation. Basically what happens in a meeting room when you were doing video conferencing or teleconferencing with loudspeakers involved is when the audio from the far end, so from the people on the other side of the call, comes back into your loudspeakers, it gets obviously picked up by the microphones. And then ordinarily this audio then would just be sent out over the phone again. So for the person talking on the other side, you would hear this weird echo. So what AEC does is it kind of applies a filter that we call an adaptive filter and sort of deletes or removes the return audio from the audio that's going out to the far end. So the reference, let's quickly have a look at Q-SYS Designer here. This is the AEC block. So if we just follow, I'm assuming that most of the people looking at this have seen this before, or you're working through the level 1. So this is actually a sample design that's available in the Q-SYS thing. So we can see the audio from our microphone, and the first component that it hits in the signal chain is the AEC block. So inside that block, the audio that was returning from the far end gets scrubbed or deleted. So to do that, the AEC block needs what we call a reference signal. So the reference signal is actually the audio that's coming out of the speakers in your room. So if we look at this mix over here, we can see that one output of it is feeding the far end via VoIP or USB, and the others are feeding a mixer. If we have to open this, we'll see that we are sending the VoIP and USB out, which is conceivably the audio coming in from the far end, out to our speakers. So the audio that needs to be sent back into our AEC ref is all of the audio that's coming out of the room speakers, and ideally with all of the processing that's being applied so that the AEC component can build its adaptive filter quite accurately, so it knows what to be listening for and what to delete. Now, in the AEC block, you have a thing on the side here called shared reference. Now, obviously, different system configurations require different things. In this context here, we're assuming that we have a single mic with multiple loads, like an MXA910 or a Team Connect or something like that. So we can assume that the reference signal that needs to be supplied to the AEC would be the same for all microphone inputs, because the microphones are all located in the same room and more or less in the same place. If you had a very big auditorium with maybe microphones on stage and microphones in the audience where there was a very different sound or a very different reference signal that the AEC block would be listening for, you can disable this shared reference, which would then expose a reference input for every matching input of the AEC block. But for most, especially for conference room applications, we're using a single shared reference because the microphones are more or less hearing the same audio that needs to be cancelled out. I hope that answers that question.
Just once again, guys, even after this, if there's any questions or some more training that you need, yeah, just email us at training@stageaudioworks.com.
There was one question here from DC. How often do the level 2 trainings hold annually? Usually we try to do 1 or 2 per year. The amount of programmers out there is quite small, especially guys that are doing more complex systems outside of the level 1 level type of skill. But this is totally demand driven. So if we feel that there's a demand for a level 2 course, we'll run one on demand. But yeah, stay tuned to our social media for information on that. Cool.
Yeah, no, from my side, that's it. Yeah, please get in contact with us, speak to us. We're here to help you guys to assist.
Yeah, and Q-SYS, it's really an amazing tool. It's been a game changer for our company. And I think it's really the answer is usually yes. So if there's a system design you want to do, 99% of the time it's possible. But yeah, we're able to assist with any questions you have about implementation or design for any Q-SYS related stuff.
And it's not ideal, but I've even built a live sound mixer, which I use about once a month using a Q-SYS core. Obviously, you have to design it yourself, but that's also a nice thing. You can decide what you want to see where, and it works fine, flawlessly, no issues. And I've got an iPad walking around in the room. Artists can have their own monitor mixes. So another example how flexible it is.
And we're using, I mentioned earlier, we have an interesting project at hand at the moment for a provincial legislature building where they're wanting to do a multilingual web stream with translators sitting at home because of lockdown conditions. So we're able to, with Q-SYS, deploy a kind of multi-instance SIP to Dante bridge, which is quite interesting because translators could then dial in to the core with a soft phone or with a cell phone or something, and contribute the translation audio, and Q-SYS will embed that on the web stream via Dante. So there's a whole lot of crazy design ideas that are possible with just a simple black box in a rack, where previously you would have needed really complex and expensive hardware to do that. So talk to us. We are nerds. We love talking about these things and doing crazy stuff with Q-SYS. So there's also a Facebook group if you get into more advanced Q-SYS stuff. It's not moderated by QSC, so there's some abrupt honesty going on there sometimes, which is good. But the QSC development team are hanging around in that group as well, and you can see and get some insights from what a lot of integrators overseas are doing. Yeah, with that, I think I've said enough. MCA, thanks so much for participating.
Thank you, Nathan. Thank you guys for attending.
Thanks so much for coming.